And if you'd be so kind as to write prime numbers on top of the first one. Prime numbers. And the definition of a prime number, make sure you have this written down in your notes, because I will ask specifically. Prime numbers are numbers that have exactly and only two factors. Numbers, or numers as I wrote there, numbers that have exactly and only two factors. And just for fun, we're going to write these down here. Let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If I asked you to list all the factors of each of these numbers, let's just do that real fast. Factors of 1 are just 1. Factors of 2 are 1 times 2. 3 would be 1 times 3. 4 would be 1, 2, and 4, correct? 5 is 1 times 5. 6 is 1. God bless you, 2, 3, 6. 7 is 1 and 7. 8 is 1. 8, 2, 4. I probably could stop there, but let's keep going. 9 is 1 and 9, right? No, 1, 3, and 9. 10 is 1, 10, 2, 5. We've done factors before, have we not?
Yes.
12 is 1, and 12, and 2, and 3, and 6, and 4. 13 is 1 and 13. 14 is 1, 14, 2, and 7. 15 is 1, 3, 5, and 15. 16 is 1 and 16, and 2, and 8, and 4. Went through those fast because we already did that. So, if you look at what the exact definition of a prime number is, prime numbers are numbers that have exactly two factors, which would mean 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number. What else? 11 is a prime number. 13 is a prime number. Another way, a lot of times we talk about it, but you have to be very careful. We sometimes say prime numbers are numbers that you can't be divided by any other number besides 1 and itself. But you have to be careful with that because a lot of times people say 1 is a prime number and 1 is not a prime number because it has to have two factors. Another thing to note is this. Maybe we should jot this down. Maybe this will make sense to you. 2 is the only even prime number. Two is the only even prime number. Any idea why that is? Why is any other prime number, any other even number not prime? It's a simple little fact there, Trev. Yeah, but why? Basically, simply, why put Colin?
Because all even numbers have halves.
Right, because you can divide any even number has 2 as one of its factors somewhere. Because you can divide them always. Any even number can be 2 times some number. So 2 is the only even prime number. And please don't think in your mind that just because a number is odd that it's not prime. Because we have odd numbers that aren't prime. 15 is odd, it's not prime. 7 is odd, it is prime. 9 is odd, it is not prime. So don't get it in your head that, just because a number is odd. For example, if I gave you 111, you might say, well, that has to be prime because it's an odd number. That's not true. Actually, 111 is not a prime number. Which leads us to the next piece of blank piece of paper. Take out another piece of blank paper. On a completely related subject, on top of this piece of paper, write the word composite. Composite numbers. And maybe you can guess what these are. Composite numbers are numbers with more than 2 factors. Numbers with more than 2 factors. I don't know if I can go back to this or not. You probably won't like me for doing this because you can't do this. Maybe you could, I don't know if I can do this. Oh, yes, you can.
Oh boy. Teleportation.
Uh-oh. Which means this. If you look at the numbers that we have up here, first of all, does 1 have more than 2 factors? It does not. 1 is not prime or composite. It's its own little entity. But any number up here that I don't have circled is a composite number. 4 is a composite number. I'll square these. Oh wait, 5 should have been prime. 6 is a composite number. 8 is a composite number. 9 is a composite number. 10 is composite. 12 is composite. 16 composite. 15 composite. 14 composite. 13 should have been prime. Did I miss those or did we just not get there? I probably missed. Okay, so every number besides 1 is either going to be prime or composite. And the nice thing that you know about that is every even number, kind of along the same lines as what we talked about 2 with the prime being the only prime number, you could also say that 2 is the only even number that is what? That is not composite. So right off the bat, if I gave you the number 762, you would tell me that's a composite number because you know that 2 is one of its factors. So you automatically know it has 3 factors. And what would those 3 factors be? Well, every number has 1 as a factor. Every number has itself as a factor. And every even number has at least 2 as its factor. So you automatically know it has at least 3. It's going to have a lot more than that, but we know for sure it has 3. So this would get my proverbial green box square for being a composite number. So welcome to the world of composite numbers. Let me see if they ask you any questions here. They might ask you to list, this would be under prime numbers, but if they ask you to list the first 5 prime numbers, what would be the first prime number we come to? 2, and then 3, and then 5, 7, and then 11, right? Because 9, 3 goes into. So these are the first 5 prime numbers. What about the first 5 composite numbers? Well, looks like we have 4, 6, 8. Who's not a prime number?
9.
Oh, well, who put? Well, we said 11. Did I write 9 and we said 11?
Yeah. We said 11.
Sorry about that. 4, 6, 8, 9, and what's the next composite number?
10.
10. Did I get those right?
Yeah.
Sometimes we struggle a little at the big boys. But now that new sunshine is here. What other questions did I ask this? I suppose, go back to your notes under prime numbers. Let's go through this. Can I clone that? What does that have here? What does clone mean? If I clone, does that keep moving clone?
I think there's sunglasses. Sunglasses for aliens.
Way. What's he doing? Wow.
He's cloning that.
How do I turn off
Oh,
the
no,
it's
it's
gonna be
square.
an clone
Is there a way to turn off the clone?
I do.
We'll just leave that there. Now, something to think about here, because you'll see the book tries to show this to you in a little different ways. This is the number 1, 2, 3. There are what, 6 of those? Those are 6 of those. And the book wants you to get into the thought process of this. One way to think about prime and composite numbers would be this. We know that 6 is a composite number, right? If 6 is a composite number, when you have your, we call the whatever array of tiles, if 6 is a prime number, then you can take these rectangles, arrange them in a different grouping, and still get a rectangle. See, this is a 1 by 6 rectangle. I could also do this. I could make a second rectangle with 6 by making a 2 by 3 rectangle. And this would be a 3 by 2 rectangle, which are all of the factors of 6, right? If you look at it, you can have 1 times 6 to give you 6, or you can get 2 times 3. Whereas if you're looking at composite numbers, or I mean prime numbers, if you have 5 squares, the only way you can arrange that to form a rectangle is a 1 by 5 rectangle. I can't change these rectangles, or these squares, to make any other rectangle other than that. You know, if you had 24 squares, I can't do it. Well, I could do that. But I have a lot of time. Can I change this? Let's copy that. We'll go here. Oh, what happened to my clones?
They abandoned you.
Don't worry, I can still do it again. Here with this.
What? What?
Let's do a clone. Wait, no, I'm good.
Oh.
No, I want a clone. Alright, if you had a 1 by 12 array, what is that? 3, 5, 6, 7. Oh, maybe we should just do 8. No, let's do 12. 8, 9, 10. Do I have 2 more spaces over there? Sure. 11 and 12. What other way could I arrange those so I still have 12 squares, but I still make a rectangle? Colton, I could do a, not 1 by 12, but a what? 2 by 6. 1, 2, 3, 4, I missed on that one, 5, 6, 7, 8, 9, 10, 11, 12. 2 by 6 would give me another way. What's another way I could do it? I could do a, Trevor,
3 by 4.
3 by 4. 1, 2, I'm gonna run out of room. Let's just go there. 3, I should make them different colors. 4, 5, 6. I have to do 4 of these? We'll never get there.
Just do one here.
3 by
I'll just put them right here. This is like Tetris. Alright, we're gonna stop there.